Welcome to 5.3. Today we're going to talk solving addition and subtraction equations. Our learning objectives: being able to solve single variable addition equations, being able to solve single variable subtraction equations, being able to recognize and apply the addition and subtraction properties of equality and the inverse relationship of addition and subtraction, and being able to model and solve real-world problems using addition and subtraction equations. Make sure to read our beginning of the lesson problem before moving on. A variable may be used to represent a particular number. For example, in the algebraic equation below, the variable represents only one possible number, x plus 3 equals 5. What number does x represent? We can find out by asking ourselves a question. What number, when added to 3, equals 5? We can solve this one using mental math. Mental math is one strategy for figuring out an unknown variable. If x plus 3 equals 5, then x must be equal to 2, since 2 plus 3 equals 5. However, to solve a more complex equation, such as x plus 34 equals 72, we may need to use a different strategy besides mental math. Let's take a look at one strategy for solving that equation now. When mental math is not an option, one strategy for solving an equation is to isolate the variable in the equation. Isolating the variable means getting the variable by itself on one side of the equal sign. One way to isolate the variable is to use inverse operations. Inverse operations undo one another. For example, addition is the inverse of subtraction, and subtraction is the inverse of addition. Multiplication is the inverse of division, and division is the inverse of multiplication. So how do we do that? To solve an equation in which a variable is added to a number, we can use the inverse operation, subtraction. We can subtract the number that is being added to the variable from both sides of the equation. You must subtract the number from both sides because of the subtraction property of equality, which states that if two things are the same and you take the same amount away from each thing, they will still be the same afterwards. In math terms, it looks like this. If a equals b, then a minus c is equal to b minus c. If you subtract a number, c, from one side of an equation, you must subtract that same number, c, from the other side too, to keep the values on both sides equal. So to solve for x in our equation, x plus 34 equals 72, to undo plus 34, we can subtract 34. And if you do it from one side, you have to do it to the other. So this 34 will cancel out there, giving us x, and then 72 minus 34 gives us 38. So we can say that x equals 38. When we solve for b here, 1.5 plus b is equal to 3.5. Right now we're adding 1.5, so to undo that, we can subtract 1.5. And if you do it from one side, you have to do it to the other. These cancel out, leaving just b. 3.5 minus 1.5 gives us an answer of 2. So b equals 2. Some more examples here. We've got x plus 36 equals 90. Again, to undo plus 36, we subtract 36 from both sides. These cancel, leaving just x on the left. 90 minus 36 gives us 54, so x equals 54. For x plus 27 equals 35, to undo plus 27, I subtract 27 from both sides. These cancel out, leaving just x. 35 minus 27 gives me 8. My answer is x equals 8. Go ahead and pause the video, solve the last one on your own, and then hit play and see how you did. To solve, you should have subtracted 1.7 from both sides, and you'd get an answer of y is equal to 4.8. So now to solve an equation in which a number is subtracted from a variable, we can use the inverse of subtraction, which is addition. We can add that number to both sides of the equation to solve it. You can think about this as working backwards from the operation. If we have a problem with addition, we subtract. If we have a problem with subtraction, we add. We must add the number to both sides of the equation because of the addition property of equality, which is very much like the subtraction property of equality, and goes like this. If a equals b, then a plus c equals b plus c. So if you add a number, c, to one side of the equation, you must add that same number, c, to the other side too, to keep the values on both sides equal. So if we're solving for a and we're given a minus 15 equals 18, to undo minus 15, we add 15. And if you do it on one side, you have to do it to the other. So these cancel out, leaving just a on the left. 18 plus 15 gives us 33 on the right, so our answer is a equals 33. Now we're going to solve for k. K minus a third is equal to 2/3, so to undo this minus 1/3, I add 1/3. If I add it to one side, I have to add it to the other. These cancel out, leaving just K on the left. 2/3 plus 1/3 equals 3/3, which is the same as saying K equals 1. So remember, those rules work for adding decimals and rational numbers as well as subtracting them too. A few more examples here. We've got x minus 44 equals 22. To undo minus 44, we add 44, and we do that to both sides. Cancels on the left, leaving just x. 22 plus 44 gives me an answer of x equals 66. X minus 1.3 is equal to 5.6. To undo minus 1.3, I add 1.3 to both sides. These cancel out. I'm left with just x on the left. 5.6 plus 1.3 gives me an answer of x is equal to 6.9. Go ahead and pause the video, solve the last one for y, and then hit play and see how you did. To solve this one, we should have added a fourth to both sides, giving us an answer of y is equal to 3/4. So now we're going to use those properties to solve real-world problems. Okay, so we're going to have to write and solve the equations, because that's the best way to work through these real-world problems. The number of gray tiles in a bag is 4 more than the number of blue tiles. There are 11 gray tiles. So there's 4 more gray than blue. So if I wanted to write an equation to represent B, which is the number of blue tiles, I would take B and I would add 4 to it to get the number of gray, which is 11. So my equation is B plus 4 equals 11. So if I'm going to take that equation and solve for B, to undo plus 4, I'm going to subtract 4 from both sides. The 4's cancel out, leaving just B on the left. 11 minus 4 gives me 7. I know that there are 7 blue tiles in the bag. Harry earned $19.50 this week. That is $6.50 less than he earned last week. So write an equation to represent M, the amount of money in dollars that he earned last week. So I'm going to use M to represent the money he earned last week, and it was less. So we're going to subtract that $6.50, and we're going to get what he earned this week of $19.50. So our equation is going to be M minus $6.50 is equal to $19.50. So to solve that equation, to undo subtraction, I add. So I'm going to add $6.50 to both sides. The 650s cancel out on the left, leaving just M. 1950 plus 650 gives me 26 on the right. So I know that last week he earned $26. Here's the end to the beginning problem. Make sure to read through that before moving on. Just some things to review. When solving for a variable, isolate the variable by using inverse operations. Whatever you do to one side of the equation, you must also do to the other side. Isolating the variable means getting the variable by itself on one side of the equal sign. Inverse operations undo one another. For example, addition is the inverse of subtraction, and subtraction is the inverse of addition. Multiplication is the inverse of division, and division is the inverse of multiplication. The addition property of equality states that as long as you add the same quantity to both sides of the equation will remain equal. The subtraction property of equality states that as long as you subtract the same quantity from both sides, the equation will remain equal.